Hello everyone, this is Navin Kumar. Today my topic is about fly-by-wire in the subject of aircraft stability and control. And my and I am from Aero Section A. And the contents which are going to discuss today is about the fly-by-wire system and need for the fly-by-wire system, history of fly-by-wire system, and introduction and flowchart of fly-by-wire system and electronics of fly-by-wire system and controls of aircraft and working and basic control loops and the types of control fly-by-wire system and the applications and the advantages and disadvantages of fly-by-wire system and some of the conclusions of fly-by-wire system. Here we are seeing an aircraft which are the aircraft but powerful system responding efficiency in order to facilitate desired outcomes. As we all know that the aircraft systems can control the aircraft. As the system is powerful, the aircraft will also get maneuver and some of the advantages and get stability. Like many other advantages will be there, and the need of fly-by-wire system. Traditionally, there are some of the controls were used in the aircraft, which are gyroscopes, which the response of the system is not linear as an fly-by-wire system. The remote control cannot be achieved. As we all know that lift is equals to flow v square a into CL. So it cannot be achieved by these systems which are and traditionally used. So the flights overly responsive at higher speeds and less responsive at lower speeds uh, by uh, by the other gyroscope techniques. Whereas fly-by-wire is wire system is not like that. And the flight's maneuverability depends upon speed, strength, and agility and the control, as we all know. So these are controlled by the control surfaces, which are which will control the speed, control, and strength and agility.
The history of fly-by-wire system. Mechanical and hydraulic connections are replaced with electronic ones. The electronic signaling of the control surfaces was tested in 1950, and in 1972, the fly-by-wire aircraft was tested for flying. Introduction. Fly-by-wire implies a purely electrical signal control system used in a general sense of computer configured controls. The computer system is interposed between the operator and the final control actuators. Manual inputs of pilot is modified in accordance with control parameters. Inner view of a fly-by-wire system. As we are seeing an aircraft which is completely designed with a fly-by-wire system, and the control surfaces which are connected by the fly-by-wire system, the control surfaces like primary control surfaces like radar, elevator, and the aileron, and the secondary controls is like flaps and snaps, which are connected with the fly-by-wire, and these are operated with the from signals and the circuits. And in the cockpit, the avionics is also connected by the fly-by-wire system. These are controlled by the flight control computers. The typical flowchart of a fly-by-wire design system. The pilot stick. It is connected with the pilot control computer, and it is connected with a data sensor. It is connected by the some of the pitot tube air measuring instrument to measure the velocity of an aircraft. And some of these flight controls computer is passes the signals to the actuators, which will operate the control surfaces, and the actuator piston feed mechanism, and the response is received by the aircraft dynamic and it will process through the pilot as well as motion sensor and as to the control computer. Electronics in a 5 by 5 system. Microcontroller becoming very popular, and basically it is a 80 microcontroller is used in the aircraft. Advantages. It is the fast response inbuilt ADC reprogramming. Controls of aircraft. As we all know that the controls of aircraft are mainly pitching, yawing, and rolling. And these are controlled by using the ailerons to control the roll, and user of radar is to control the yaw, and the use of elevators to control the pitch. Working. Pilot sends controls to the pilot sends control to the link and transmitter, receiver RX translators into the 50 hours of power watts of mega signals between 1000 to 2000 milliseconds in a pulse with set point. Gyro translated and compared with the RX pulse width. Difference between the set point and gyro reading. Error signal point. Error signal feed to PID controller along the velocity data. Final signals passed to servo actuator make the aircraft and change its flight. The basic control loops as the pilot to PID to gyro, and gyro to RX. RX, it is received by the roll, pitch, yeah, and switch, and the error is received. And there it is connected with some servos. Simple feedback system of a fly-by-wire system, reference to the controller to the system, and the measured error is connected with the system output through the sensor. There are two types of fly-by-wire system. One is analog system, another one is the digital system. Analog, the replacement of hydraulic or mechanical control systems over the electric circuit. The control system in a cockpit operates signal transmitters to generate the appropriate electronic commands in signal, then processed by an electronic controller with analog signals. And the digital system, a digital fly-by-wire control system, is similar to its analog counterpart. Pilot rhetoric can fly by computers, increases flexibility of a flight control system. Multiple redundancy techniques and increase the electronic stability as system is led to depend upon the values. Comparison. The difference between the analog and the digital system. These are the two techniques in the fly-by-wire system, as they have their unique properties in comparison to this system. One is the accuracy is low, and other one is the accuracy is high, and the circuit uh, complication. The circuit is simplified, and the calibration is tough. The calibration is easy. As we all know, the digital world is easy as we compared with the analog system. So the accuracy of the computer by spotting the signals is very high, and the circuit's complication is little bit high when we compared with the digital system, as we know. And the calibration is tough, and the calibration is very easy. The application. It is used in the military and civilian aircraft. Satellite manufacturers use technology in their vehicles and spacecraft, space schedules, and several unmanned aerial vehicles, UAVs, and the Airbus, Boeing, Thunderbolt, and Sun, Shield Bomber, and MiG-29K. Advantages: reduced wear and tear due to less mechanical contraction, intelligent control system, high accuracy and greater maneuverability, and safety, increased safety and reliability, improved survivability, mission performance, easy of assembly and maintenance. Disadvantages: some software failure due to hacking and technical issues. Conclusion: consisting of pilot controlling aircraft, configured computer system used to make aircraft stable and maneuverable. Thank you.